wondered how to search for something inside a vast amount of data when the original given data is not sorted at all? So, welcome to the world of linear search, the simplest yet one of the most powerful search technique. In this video, we will not only understand how it works, but also how to code it, analyze it, and even how to optimize it. Let's dive deep. This is not just a tutorial, this is your linear search masterclass. So let me take you to the whiteboard to make it more clear for you to understand what does this linear search means. Now suppose I am having 10 boxes and I have kept them all in a line. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now these are the 10 boxes and in one of any of the box I have kept a stone, and the information in which box the stone is only known to me. Except me, no one else knows where the stone is. And now in this condition, if I ask you to find the box in which the stone is, suppose you are standing here, and if I ask you to find the box in which the stone is kept, so you can either follow a hit and trial method in which you can go to the box, open it, stone not present, leave the box, go to the another box, stone not present, go to another box, stone not present, go to another box, stone not present. And after searching for a number of boxes, you can possibly reach the stone. But this does not show the 100% surety. But this method is good, but it is having a problem. Suppose if there is a vast amount of data, the number of boxes is very large, it is 10,000 or even more, then how you can search for the box in which the stone is? It will take a large amount of time. Now, to optimize this time or to make it even easy to get the box, the second method which you can follow is you start from any of the end. Suppose you started from here, go to the first box, check if stone is present, stone not present. Go to the second box, check if stone is present, not present. Go to the third box, stone is present, not present. Now go to the second, that is fourth box, stone is present, not present. Then go to next box, here also stone not present. Go to next box, stone not present. Then go to next box, here you will find the stone. Now this method of searching looks more technical, and this is what the linear search means. Now at this point here, you may ask question, can we start the linear search from other end? Then its answer is yes, we can start the linear search from any of the end. There is no foundation that we should start the linear search from left or right. This is the biggest misunderstanding of the beginners who start to learn, that we should always start from the left. In linear search, there is no such foundation. We can start from any of the end. Now suppose if I start from this here, I reached here, there is nice, the stone is not present here, then I can reach this box, stone not present, then I can reach this box, stone not present, then I can reach here, here stone is present. So we can we can follow any method from starting or from the end. This is known as the linear search. Now this is the overview, general overview. This is good to understand what does linear search means, but I don't think this is more technical. So let us make this more technical step by step. So let's take one more example which is more technical than this, and it will make the linear search more technical for us to understand. Now suppose this is the second example and this is you standing at this place, and this, the numbers written here, is your phone book, which is having only one structure, that is, in this phone book there are some random numbers written which are the mobile number of the person whose name is written just after the mobile number. So if one day you desire to find the mobile number of any person, suppose one day you desire to find the number of Nick, which is written inside in somewhere in that phone book. So how you can do that? You can open the phone book from starting, read the first mobile number, read the name of the person. If it is Nick, then it's okay. But here it's this number. The first number is of Steve. Leave this number. Go to the second number. Here this number is of Tony. This is also not the Nick. Leave this number also. Go to the third number. This number is of Bruce. This is also not the number of Nick. Go to the another number, means the number which is followed by this number. This number belongs to Sam. Then continue your searching. Here, go to here. Then you, after some time, you will reach here. Now you found that this is the number of Nick which you were searching for. Now you stop here because you found the your desired mobile number. This is what happens in the linear search. I hope this is more technical to understand for you. What does that linear search do? It starts a loop from one of the end of the given data, either from the starting end or from the last end, and search for the data, desired data that we are searching for. It starts iteration from first end and start to reach till the last end till we don't get the data. And once we get our desired data, it works according to our conditions. And there is one more condition existing in this. If suppose you are searching for a data which is not present here. In this example, if you search the mobile number of Clint Barton, it is not present here. So you will start the iteration from one end and will reach to the last end, but you will not get that data. In that case, it means the data is not present in our data set. If we start from one end and reach to the final end without finding the data, that means the data set is not present in our data. Now, instead of its too many advantages, why this linear search is not very common? Because it has one disadvantage, and that is it is time consuming. But in previous years, before we had super smart search engines and lightning fast algorithms like binary search or hash maps, things were simple and manual. Imagine it's 1950s. Computers are just starting to emerge. No Google, no fancy data structure, just rows of punched cards or list of numbers stored in memory. Now a scientist want to check if a specific number exists in this list. There is no sorting, no indexing. What do? They start at the beginning, card by card, number by number, until they find the match or reach the end. This is how this linear search got place in this IT industry. Now let's try to understand the code of this linear search. Now to test our code, I have reached to the VS Code where I have opened a folder named as new folder. In this folder, I am creating a file named as searching.java. Now in this file, we will first create the main class. Now we will start to write our code from this end. Now here I am creating a scanner. C scanner C is equals to new scanner system.in. Now here this scanner is giving error because we have not yet imported the scanner class. For that I have to import java.util. Now this line import java.util.scanner will import the scanner class from the libraries. Now first we have to get the number of the data sets. For that I will ask the user to enter the number of data sets. Enter the number of elements in the array. Now after that the user will enter the number of the elements. Now when the user will enter the value, we have to store that value into a variable. For that I am creating an integer variable n which will get that value from the user. sc.next int. Now this n will get the value from the user. Now here I am creating an array of integer type to store the elements. I am giving here the name of array as numbers. Now int, and it will be the size of the array will be n. So again I am printing this statement to get the elements from the user. Enter the elements of array. It will be elements. Now here the user will enter the elements of the array. Now I will start the for loop to get these elements. For I is equals to 0, it will start from 0 and it will run till it is smaller than n and will update itself by one value at each iteration. Now I will store that value into the numbers I at the ith index in number array. And now I will ask the user to enter the number which he want to search. For that I am writing enter the number you want to search. After reading this line, the user will enter a number which he want to search. I have given it the name target and I have declared its data type as integer. Now here I am taking an integer value flag as 0. Now I am starting a for loop starting from 0 moving till I is smaller than n and will update itself at each iteration at y value 1, and if at numbers I it gets the target. If the target value becomes equal to the element into the number array at index I, then our flag value will get updated by 1. Means the flag value will increment by 1. Now in last, if we will check if our flag value is greater than 0, means is there any change done in the flag value, means is there any increment which have been done in the flag value, then we will print the statement thus target value is present in the array. And in else condition, if the flag remains same, means its value did not change, then we will print the target value is not present. The target value is not present in the array. Now this is the code for the linear search. Let's try to run this code. Okay, here. Now, when I have run this code, it is saying that enter the number of elements in the array. Suppose I am giving it 5. Now it will ask me to enter 5 elements. Here it is saying that enter the elements of array. Suppose I am writing 4, 6, 3, 1 and 9. Now these are the 5 elements which I am giving it as the elements of array. Now it will ask me to enter the number which I want to search. Suppose I want to search 6 in this array. It is giving us the output. The target value is present in the array and we can see here the 6 is present in the array. Now let's run this code once more. Now it is asking the number of elements 5. Enter the element 4, 6, 9, 2, 8. Now let's enter an element which is not present in the array. Suppose I am entering here 5. We can see it is giving the output the target value is not present in the array because in this whole array there is no place where 5 is present. And if you remember one thing, I have told that we can start the linear search from any of the end. So I am changing this for loop, means the iteration of this for loop, it will start from the end. So I am passing I is equals to n minus 1 and it will run till I is greater than or equals to 0 and it will decrease the value of I at each iteration. Now if I run this code from here, now our code is running and it is asking us to enter the number of elements. I am entering 5 and now it will ask to enter the elements. Now suppose I am keeping elements 2, 4, 6, 8 and 0. Now it is asking me to enter the element which I want to search. Suppose if I am searching 6, then it is saying the target value is present in the array and we can see the 6 is present here in the array. So this is how we can use this linear search and this is the full code of this linear search. Now let's discuss the time complexity and many more things about the linear search. So for that, let's move to the whiteboard. Now suppose the array entered by the user is 2, 3, 9, 4, 6, dot 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 means there are number of elements after this, and then I am writing 5, then again I am putting dot 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 means there are number of elements, and in last I am writing 5, 9, 9 means this is the last element. Now suppose if the target value, there will be a target now. If the target value is 2, then our iteration will start from here. It will get the value at the very first index with only one comparison. So the time complexity of this linear search in best case is big O of 1 in best case. Okay, sorry, this is case. Now suppose one more condition. If the user given the target value as 599, the iteration will start from the very first index. The pointer will start to iterate, will reach here, 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 and after a long time it will reach here in the last, and it will find that the target value 599 is present here at the very last index. So how many comparisons have this algorithm made to find this element here? You can simply say if there are n elements in the array, it would have made n comparisons. If there are m elements, it would have made m comparison. So in the time complexity of this in the first case means in the very worst case will be big O of n, because it will do n comparison to find the last element. And there is one more complexity existing. For that, suppose I am erasing this whole thing from here. And now suppose if the user have got the target as 5. Now again the iteration will start from the very first index, means from here it will compare the value. No, the value are not same. It will reach here, 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 then here, then here, and after a certain time and after a number of comparison, it will reach here, and at this place the target value 5 is equal to this value. So the 5 is present here, but how many comparisons does this have made? Now for some time think that if there are n elements in this array, means the index at this element is n, then the index of this element is n by 2. I am saying this, then agree with it. Means if there are n elements, then this is the middlemost element. So according to this condition, what will be the average time complexity? So the average case time complexity of this linear search will be big O of n by 2, but in the case of we always take the whole number, so in this average case also the time complexity will be big O of n instead of n by 2. So we have seen the time complexity of this in all three cases. In the best case, its time complexity is big O of 1. In the worst case, its time complexity is big O of n. And in the average case, its time complexity is also big O of n. This is what about the time complexity of this linear search. So here, this is the definition of the linear search. According to this, linear search is a searching technique where we start from the first element of the array and move one by one until we find the target element or reach the end. This is the very first and easiest definition of this linear search. And here a few of the points are given about this linear search. According to the first point, it can work on the unsorted data. There is no sorting required before proceeding to search the element in the data. And according to the second point, it is very simple and easy to understand. And so, as I have told, it is great for beginners. If you notice this point, the third point, it is saying checks each element one by one sequentially. Now, what does this sequentially mean? Sequentially means the linear search start from one end and moves till the last end till it don't find the element. Here, no, if you notice one thing, the second name or the another name of linear search is sequential search because of its working in a sequential manner. So this is the one of the most important thing. The another name of the linear search is sequential search. In this linear search, the data given by the user, over that data we just impose a for loop and get our output. We don't use any extra data or any extra memory to store any data. And in the fifth point, can be used on any data structure, array, list, string, etc. The linear search allows us to apply this search over any type of data structure. We can apply it over arrays, we can apply it over lists, we can apply it over strings, means any of the data structure. And there is one disadvantage of this search, that is it is inefficient for large data sets. As I have told, the linear search is not good for the large data sets. And we have talked about the time complexities of this linear search. So this is all the thing about this linear search. Finally, that's our complete breakdown of linear search from basic to advanced. If this helped you, smash that like button, subscribe to our channel Code With Me, and hit the bell icon for more DSA breakdowns. Comment below with your favorite searching algorithm or your next video request. Until then, keep learning, keep coding.